two questions. So for this note we need, we can do it in, suppose, this way. Let AZ, note that next, better we do it in next phase. Let, sorry, at first we note that ideals of Z are of the form AZ. That means AX says that X belongs to Z, where A belongs to Z. That is principal ideal. Any ideal of Z is a principal ideal. Let I be an ideal in Z. If I equals to 0, then I equals to, I can write 0Z. We're done. If I not 0, then I star, I write, not I star, I write I tilde equals to such n belongs to I such that n is greater than 0. Then I tilde is non-empty. Why? As I not equals to 0, so there exists x belongs to I such that x not 0. If x is positive, then x belongs to I tilde. If x is negative, then -1 into x belongs to I tilde. -1 into x belongs to I. Hence, minus x belongs to I tilde. So it is non-empty. So by well ordering property, of natural number, it has a list element. Tilde has a list element. Say A. Okay. Then for any n belongs to I, we can write we have unique Q and R such that n equals to a q plus r. 0 less than r less than q. Sorry, a by division algorithm. Okay, so I don't know what is this. So n belongs to I, a belongs to I. This implies n minus a cube belongs to I. This implies r belongs to I. If r not equals to 0, then 0 less than r less than a. This implies r belongs to I tilde and r less than a. Contradiction. A contradiction, as r is the least element of I tilde. This implies r equals to 0. So n equals to a q. This implies I is subset of az and this is subset of I, as a belongs to I. So I equals to az. So any ideal of Z is principal. Next we show that what is the spectrum. Okay, if next we observe that if az is subset of bz, this implies a belongs to az subset of bz. So a equals to b into k for some k belongs to z. This implies b divide a. Conversely, if b divide a, then a equals to b bk. This implies az is subset of bz. Okay. This implies a belongs to so az is subset of bz if and only b divides it. Suppose az by what is your n? N is p1 to the power alpha 1, p to the power alpha 2 dot dot pk to the power alpha k, the prime number. Suppose az by nz spec z mod nz, because you know that in a quotient ring it is of the form where ideal containing nz, where uh, nz is subset of az and and n equals to p1 to the power alpha 1, pk to the power alpha k. This implies since az by nz belongs to spec z mod nz, this implies az belongs to spec z. This implies a equals to prime number, prime. By definition of prime, P divides AB implies P divides A or P divides B. You see that PZ and 0 are the primary spectrum of Z. Okay. Prime ideal of Z or equals to 0. Prime number, I write prime number of Z or is A equals to 0. But NZ subset of AZ imply A not equals to 0. So A equals to P for some prime P. Now NZ subset of PZ AZ that is equals to PZ imply P divide N that is equals to P1 to the power alpha 1 alpha K. This implies P belongs to PK because both are primes. Pi and P all are primes. Hence, spec Z mod P1 to the power alpha 1 dot Pk to the power alpha K Z equals to P1Z quotient P1 to the power alpha 1 Pk to the power alpha K Z dot P K Z to the power alpha 1 Z. So these are the prime ideals of this. Okay. Any question? Division algorithm in AX single variable where A is a field. Let fx gx belongs to kx with gx is non-zero. Is non-zero. And we prove that yes, if R is integral domain, then Rx is integral domain. So Kx is integral domain. This is my proof. And degree of fx into degree gx is degree fx plus degree gx. Okay. Note that kx is integral domain, but not a field. This is my previous class. This was previous class. So now we will prove this. Okay, with gx not 0. So there exists unique polynomials qx and rx such that fx equals to gx ux plus rx, where Rx equals to 0 or degree Rx is less than degree Qx, sorry, Gx, if it is non-zero. I should write if it is non-zero. Rx non-zero. So proof is very easy. Use let fx equals to a0 plus a n x to the power n, a n not 0, n equals to degree fx, gx equals to v0 bm x to the power m, bm not 0, m equals to degree gx. Okay, so before writing this, we settle a case if fx equals to 0, then we take qx equals to 0 and rx equals to 0. So we are done, and we are done. If fx non-zero, then we let okay. If n equals to 0, that is if fx is degree 0 polynomial, then then case 1, a0, case 1, if degree gx is also 0, this implies gx be 0, then f can be written as uh, a0 by b0 into b0, 0 by b0 gx. Now we are done. If degree gx is positive, then write fx equals to 0 into gx plus a0, and we are done. So division algorithm is so the statement happens. Uniqueness we'll do later, but expression, it is done for n equals to 1, n equals to 0, sorry. Let us assume any polynomial of degree less than n can be written as in the form fx equals to gx into qx, q1x plus r1x. I should write degree n, so I write f1x better, where degree rx equals to 0 or degree rx, where r1x equals to 0 or degree r1x is less than degree gx. Now, for fx, if sorry, if degree fx equals to n is less than degree gx, we can write fx equals to 0 into gx plus fx, and we are done. We are done. If degree fx n is greater or equals to degree gx, we can write fx equals, take f1x, f1x equals to fx minus an by bn gx x to the power n minus degree gx. So leading term will cancel. You see that if I multiply this, leading term of fx and leading term of this will cancel. So degree f1x is less or equals to n minus 1. By induction hypothesis, f1x can be written as gx into q1x plus r1x, where r1x is 0 or degree r1x is strictly less than degree gx. So this implies fx minus an bn gx x to the power x to the power n minus degree gx equals to gx u1x r1x. Okay, so this implies fx equals to q1 gx into q1x plus an by bn x to the power n minus degree gx plus rx. Plus r1x. Take where r1x equals to 0 or say or degree r1x is less than degree gx. So take this is q x and this is equals to rx. Okay, now uniqueness. So we can express fx is q gx into qx plus Rx, where Rx is 0 or degree Rx is less than Gx. So just leading term got cancelled here, and this is the technique. Now uniqueness. Uniqueness of Qx and Rx. Fx can be, suppose Fx has two expressions, more another expression Gx Qx plus Rx, and Fx equals to Gx Q1x plus R1x, where Rx equals to 0 or degree Rx is less than P degree Gx degree Gx. Similarly, where R1x is 0 or degree R1x is less than degree Gx. So you can write it as Gx into Q1 Q1x minus Qx equals to Rx minus R1x. Comparing degree, this side, what is degree? If Q1x minus Qx is not 0, then left hand side has degree LHS has degree greater or equals to Gx, because as X is integral domain, is an integral domain. So degree of fxgx equals to degree fx plus degree gx. So here degree gx plus something, degree of this. So let's get or equals to this. So we use here in integral domain property. Okay. For uniqueness, we use here integral domain property. And RHS as degree less than gx, because Rx and R1x both are less than degree gx. Contradiction. So Q1x minus Qx is 0. This implies Q1x equals to Qx, and hence this LHS is 0, so RHS should be 0. So this is my division algorithm. So it has corollary. Let fx belongs to kx and alpha belongs to k. Then fx is x minus alpha gx plus f alpha, that is if alpha is the remainder, here Rx Qx is called quotient, and Rx is called remainder division of fx upon gx. Okay. Okay. Is the remainder of fx when it is divided x minus alpha. So you just see that by division algorithm, it is very easy proof. The division fx can be written as x minus alpha gx plus c, where c belongs to k, because quotient should be degree of 0. Okay, or it may be 0. If it is 0, then okay. Otherwise, if it is positive, if it is not 0, sorry, then degree should be 0, because it is x minus alpha is degree 1. So if alpha is c, we're done. Next question. If you have any question, please ask me. Find the remainder of fx degree fx equals to n when it is divided by number 1 x minus alpha, x minus alpha to the k 1 lesser equals to k lesser equals to n. I don't write. Okay, I just write x minus alpha to the power k 1 lesser equals to k lesser equals to n. So what is the remainder? Can you see? See, hint. If fx is divided by x minus alpha, then f alpha is remainder. Now, fx is divided by if x minus alpha whole square, then ax plus b should be remainder. Okay, so f dash x, what is this? 2, x minus alpha plus x minus alpha whole square q2 dash x plus a. So f dash alpha, what is this? A. And f alpha is a alpha plus b. So what is b? B is your equals to f dash alpha into alpha plus b. B is your f alpha minus f dash alpha into alpha. So remainder is, what is remainder? Ax plus b. A means f dash alpha x plus b means f alpha minus f dash alpha alpha. So what is this? I don't know. The key there. So rearranging the terms, I can write x minus alpha f dash alpha plus f dash alpha. So we can write 1 factorial here. Okay. Next, if I divide x minus alpha whole cube, then let fx equals to x minus alpha whole cube q3x plus a1 x square plus b1x plus c1. This should be remainder. We have to find what is a1, b1, c1. So I can say that if alpha is a1 alpha square plus b1 alpha plus c1. So what is f dash x? That is 3 x minus alpha whole square q3x plus x minus alpha whole cube q3 dash x plus 2a1x plus b1. So f dash alpha is 2a1 alpha plus b1 is number 1, 2. And what is f double dash x? This is 6x minus alpha q3x plus 3x minus alpha whole square q3 dash x plus here 3x minus alpha whole square q3 dash x plus x minus alpha whole cube q3 double dash x plus 2a1. So f double dash alpha is 2a1 only. So a1 is f double dash alpha by 2. From 2, what is b1? b1 is f dash alpha minus f double dash alpha into alpha. Now from 1, if alpha equals to a1 means f alpha double dash alpha by 2 plus b1 means this f dash alpha minus f double dash alpha into alpha, that is b1, that is also alpha plus c1. So c1 equals to your f alpha minus f double dash alpha by 2 minus f dash alpha to alpha plus f double dash alpha to alpha square. So remainder is, this is C1, this is some calculation just. So remainder is 3x. I should here write R2x, and here it is your R1x. Okay. So what is remainder? A1 x square. A1 means f double dash alpha by 2 x square. Look at this value, plus b1 x. b1 is f dash alpha, f double dash alpha into alpha of x plus c1, that is f alpha plus f double dash alpha by 2 minus f dash alpha into alpha plus f double dash alpha square. So if we rearrange this, so I can write x is f double dash alpha by 2, I common x square minus x square plus alpha square from here, and what is mine from here we get 1 minute. Okay, we get from this term, from here we get minus 2 alpha x. Okay, then f dash alpha common, what I get, x minus alpha. Okay, plus f alpha. So this is your b1. What is c1? It is very irritating. This is a1 alpha square plus b1 alpha is c1. What is a1? A1. Okay. So f alpha is, this is a1 alpha square, b1 alpha plus c1. So a1, I forgot here alpha square to write. Alpha square plus b1 alpha plus c1. Okay, now this is right. So this is equals to f alpha, this minus and this is plus f double dash alpha square by 2 minus f dash alpha dot alpha. Okay, Now it is corrected, just correct it. F alpha plus f double dash alpha dot alpha square by 2 minus f dash alpha into alpha. Now you can see that this is of the form this. So this is what f double dash alpha x minus alpha whole square by 2 factorial plus f dash alpha x minus alpha by 1 factorial plus f alpha. This is your remainder. So we can by induction, by the induction we can see that uh, so this is n minus 1, sorry, fn fn minus 1 rn. For R3 it is starting from 2, 1 less, so f alpha. So this is a remainder. When fx is divided by x minus alpha to the power n, so I can write it as fx equals to x minus a whole to the power n into qx plus rnx. Now the fx equals to x minus this is, so differentiating n times fnx equals to, I can write uh, in fact at first see that since degree fx equals to n, this implies degree ux equals to 0. This implies qx is a constant. Since x minus a whole to the power n is a monic polynomial, monic means leading term 1. I leading coefficient is 1, or degree n coefficient is 1. Okay, so this implies qx should be an. So fx can be written as an x minus a whole to the power n plus rnx. So fnx is n factorial an. This implies an is fnx by n factorial equals to, I can write it, this is constant fn alpha, so I can put alpha n factorial same as a n constant. I don't use the term constant an, I write an belongs to k. This polynomial n belongs to k. Okay, so fx can be written as now fn alpha by n factorial x minus a whole to the power n plus rn. What is the value of rn? This is your value of rn. Fn minus 1 alpha by n minus 1 factorial Oh, this is n minus 1 factorial, 1 less. This is 2 factorial. So at last f alpha. This is called Taylor expansion. Now see, there is no calculus because I am doing here arbitrary field k over the arbitrary field k. There is no analysis, but we can define what is derivative. We define just derivative of x to the power n. I define it n into x to the power n minus 1, and additively it is happening, and it follows Leibniz rule. So we can define derivative of polynomial over arbitrary field by just rule. There is no analysis. Okay. Any question? Some observation, just to note that kx quotient out x minus alpha is isomorphic to k. Hence, where alpha belongs to k. Hence x minus alpha generated ideal. I want to write generated ideal that belongs to max spec kx. This is very easy. All of you know that how to prove it. Kx to k phi define a map, fx goes to f alpha. Okay, then check that phi is a ring homomorphism. In fact, it is a k algebra homomorphism. K algebra homomorphism means the element of k getting fixed. Homomorphism. So what is phi is surjective, right? As if c belongs to k, phi of x minus alpha minus c, if x of x minus alpha plus c equals to alpha minus alpha plus c equals to c. So it is preimage, x minus alpha plus c is preimage, phi is surjective. So what is kernel? Kernel of effect of phi is those if x belongs to kx such that f alpha equals to 0. Now, if x belongs to kernel phi, if and only if alpha equals to 0, if and only if fx can be written as x minus alpha into gx plus f alpha, that is 0, if and only x minus alpha divide fx. So kernel phi is exactly x minus alpha generated ideal. So Ax quotient x minus alpha generated ideal is isomorphic to k. So you know that what is the x minus alpha generated ideal is x minus alpha into some px, such that recall that px belongs to kx. So you see that this is isomorphic to kx. Now, what is, so it is a vector space of dimension 1. So kx quotient, note that, I write, note that kx quotient x minus alpha is the k vector space of dimension 1. The question is, what is the vector space dimension of kx? Find the vector space dimension of kx quotient fx generated ideal. You know that any ideal of kx is principal. Oh, I have not proved it, right? Yet. So I can prove it by division algorithm that any ideal of kx is principal. Similar proof as zx, I can prove it. So I will prove uh, where in next line I will prove where degree fx n. Say, what is vector space dimension? Can you say? Is anyone is there? Try to answer this. What is the vector space dimension of this?
N,
N.
I think.
Yes, it is right. Or can you find a basis? Right answer, it is n. Can you find a basis? Anyone? Yes. Okay, okay. So, yes, we claim that proof that 1 plus fx x to the power n minus 1 plus fx is a basis for kx quotient fx. Hence, dimension, vector space dimension of kx quotient fx is n, exactly n. Okay. So at first we have to prove it is they are linearly independent, and then we have to prove that it is they are linearly independent, and we have to prove it for it spans this. Okay, let gx equals to kx. So gx can be written as fx qx plus rx. Okay, 0 less than equals to either rx is 0, either rx is 0, or degree rx is less than degree fx by division algorithm. Sorry. Okay, right. Rx is a0 plus a n minus 1. I don't know what is degree. A n minus 1 may be 0. Some yes may be 0. Okay. So some or all of maybe 0. If all 0, then Rx is 0. So, but Gx can be written as Gx plus Fx generated ideal coset can be written as A0 plus, I can write it as A0 into 1 plus Fx plus A1 into x plus Fx plus n minus 1 into x to the power, sorry, this is not angular, x to the power n minus 1 fx generated ideal. I can write it as. So I write s span s equals to kx quotient fx. Now you have to write, show that it is linearly independent. Okay. If suppose b0 plus b0 into 1 plus fx generated ideal plus b1 x plus fx generated ideal b n minus 1 plus fx generated ideal is 0 plus fx generated ideal. Suppose it is 0, I have to show that b0, b1 to bn minus 1 all are 0. This means by quotient operation b0 plus b1x plus bn minus 1 x to the power n minus 1 plus fx generated ideal, this is the sum in the quotient ring, 0 plus fx generated ideal. So this implies b0 plus bn minus 1 x to the power n minus 1 belongs to fx generated ideal. This implies fx divide b0 plus bn minus 1 x to the power n minus 1 generated ideal. But degree fx is n and degree of b0 it is n minus 1. This implies b0 equals to This implies these elements is 0. This element should be 0, because if it is non-zero, then degree is n minus 1, which is a contradiction. It is 0 by definition of polynomial equals to 0. So S is linearly independent. Okay. Any question? Can you find these rings? I will show that next day, that what are the ideals of kx. That means kx is all ideals are 0 or principally generated. All ideals are principally generated. We'll show that next day. But right now, can you answer this? What is your answer? Find zx. I should choose 5, 6, 7. Can you answer this? 9. These are some quotient tree. We have to find isomorphic ring of this. Can you try this? I think 8. There are 8 questions. 7. This is 7 marks. 7, and that is 8. I will add more to 9. Uh, no, not this. Okay. No, because I want to stay only on one variable right now. Then I will go to uh, more several variable polynomial ring. But right now in one variable. So with the answer, anyone? Can you answer this? Anyone? Z, what is your Z square bracket I? Uh, can you say that that is A plus BI where AB are integers? Okay. So you have to apply division, but note that here the ring is ZX. It is Z is not filled, but x square plus 1 is monic. So you can apply division. Okay. At first you try this at home. Next day we will discuss this and Chinese remainder, prime evidence, it's etc. Okay. Number 8 is very interesting because this is not monic. 2x minus 1. Okay, anyone have any question? क्वेश्चन है तो बताओ. Okay, then I am leaving.